We can have some more ideas. I'm just going to take a two-dimensional case here. We have taken the two examples in three-dimensional case, and I can describe you how we are defining the functions in that case. So this is my next example, example 5. So I'm going to give some more examples, and I'm going to take an example in the plane. This is my example 5. We're given the vector value function r of t, that's t I plus 9 minus t squared j, and the domain of the function is from -3 to 3. I want to find here, number 1, that we want to describe the curve. Number 2, we want to sketch the curve. And number 3, we want to sketch the vectors when t equal to -3, -2, 0, 2, and 3. So we write the parametric equations of the curve. My x is equal to t and y is equal to 9 minus t squared. From these two equations, I eliminate my t. So in this way, we get the equation in the rectangular coordinates, and we can describe it more easily. So I put here my t is equal to x. So my y is equal to 9 minus x squared. And this is my parabola. So one thing is, the equation is representing the parabola, number 1. So it's opening downward because here x is negative. We say it's opening downward. If it was positive, then it was opening upward. So it's opening downward. B is want to sketch the graph. Now to sketch the graph, we having xy plane. This is my y-axis, and this is my x-axis. And here I am having here 0. This here is 1. This is 2. This is 3. And here is -1, -2, and -3. This is from -t to 3. Now I am having the points. When we take the value of x equal to 0, I am having the value of t, and then I have the value of x, and I have the value of y. When t is equal to 0, then x equal to 0, y equal to 9. When t is equal to 2, then we are having here y is equal to 5, 9 minus 4. When it's 3, then we are having here this 3, and the value of this one is 0. So we can have here the value of is -2, then again we are having here 5, because t squared is 4, and 9 minus 4 is -5. And -3, again, t squared is 9, 9 minus 9 is 0. So we sketch these values. We are having here this point which we are getting from this table. So I'm having here this point is when t equal to -3. When t equal to 0, we have the value is 9 here. I can say here this is my value. Value is 9. When t equal to 0, this is 0, 9. And this here is -3, and the value of y is 0. This value is 3 and 0. Then we take here 2, the value is 5. I take here this one as the value of the point, and 2, the value is 5. So you sketch this one. My sketch of this one going to be here. We start from here, and then reaching this one, coming back, and then reaching this one. This is my graph of the parabola opening downward. Then number 3, I want to find here the, I just take this color, and I want to find the vectors. Here number C, I want to find the vectors when r equal to 0. When r equal to 0, then r0 is equal to 0, 9. And I have r1, r2 is 2, 5. And I'm having here r3 is 3, 0. And r minus 2, I can just take it from here, is equal to -2 and 5. And r minus 3 is equal to -3 and 0. Now I can draw these vectors, and with the help of this, we can see it here how the vectors are being shown. And we are having this vector. This is my vector r3, r minus 3, r minus 3, and this here is -2, and this my vector is r minus 2, and this my vector is vector here r0, and this vector here is r2, and this vector here is r3. So these are the points here in this example that we just having this example. We're given here the vector value function plane, and we want to describe it, we want to sketch it, and we want to describe the vectors. So here we are having this curve, and we say it's -3 to 3. And the curve is running here from -3, it's going like this. This is the direction of the curve because it's from -3 to 3, so going like this one. So here is the sketch and the description and the vectors. We take another example, and our next example, I want to skip the example. I just want to give you some notes, the idea that how we can find the vector value function from the vector value function over equations for the in rectangular coordinates. For example, I'm given here r of t is equal to, given to us is at square I plus 2atj. Now this is a parabola. When one of the vector value function is power 2, other is power 1, then definitely it's a parabola. How we can see it? So it's my x is equal to at square, and my y is equal to 2at. I get the value of t. My t is equal to y upon 2a. I put the value of t here. My x is equal to a into y square over 4a. I simplify this one, 4a square. I get here x is equal to y square over 4a. If I multiply with 4a, I get here y square is equal to 4ax, and it's my parabola. It's parabola. So in the last example, we have the quadratic term was our y, and the linear term was x. So we have the parabola, and we are having here now the quadratic term is f of t, and the linear term is g of t, this x and y. So we can get this parabola. Note 1. Note 2. We can have given the equation in the following form. We're having here the equation given r of t is in terms of cosine and sine is a cosine ti plus b sine tj. We're given this one, and want to see what does it describe. Obviously, we are having here this my x is equal to a cosine t, my y is equal to b sine t. So here I get the value of sine t and cosine t. So my cosine t is equal to x over a, and my sine t is equal to y over b. Now use the trigonometric function formula. This cosine square t plus sine square t is equal to 1. I substitute the values. I get here x square over a square plus y square over b square is equal to 1. What does it represent? This represents the ellipse in xy plane. So that's the idea. If we're having sine cosine function with positive sign or negative sign, in that case, we are always going to get the ellipse, not the hyperbola. We're going to get the ellipse because the formula is cosine square t. If negative become positive, sine square t negative become positive. And so we get here x square upon a square, y square upon b square is equal to 1. That's our ellipse. So that's the idea. We can just see on the equation, and we can have, as we have the 3 dimension, then we have x equal to 2. This means it's in the plane x equal to 2. We can have two functions, for example, x and y, and z equal to 3, or z equal to some value. So in xy plane, it's parallel to xy plane. X equal to 0, z equal to 0 means xy plane, z equal to 1, z equal to 2, z equal to -1. That's mean parallel to xy plane. And we are having the function, for example, we take sine and cosine, in that case, this will be the set of the ellipses. So that's the idea. We have just done in the quadratic surface also. These ideas, we have used it, and we are using it here.